All right, guys, this is a continuation of 4.3. All right, so we're still in 4.3 with this. Okay, guided notes for today, so there you go. Now, let's talk about, we've talked about solving radicals, but we really haven't talked about where this applies. So how can this be useful? All right, so solving radicals and inequalities, basically you can use in real life problem when I'm using radical equations. In a hurricane, the average wind velocity can be modeled by V times P, which is pressure, equals 6.3 square root of 1012 minus P, where P is the air pressure at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the average wind velocity is 55.5 meters per second. What do we know? So, first thing is, let's go down. We know that we're talking about wind velocity. We are given an equation right here. And we know our wind velocity for our problem is 55.5 meters per second. All right. So this is your first taste kind of at the real world scenario, so to speak. I'm going to put the others behind here. Just give me 1 second. There we go.
Am I going to be in a hurricane and I'm doing this in the...
Obviously not. But for those of you who might go into meteorology or more physical sciences, you're starting to see where this math applies. So let's write down what we know. We know that our V of P, our velocity at the pressure, or given pressure, is 6.3 times 10, 12 minus P. And we know that our V, our given V, is 55.5 meters per second. Okay, now that's pretty fast. To put that in comparison, there's roughly 3 feet in a yard, in a meter. Sorry, 3 feet in a meter. Okay, so multiply 55 times 3. It's roughly 3, 5, 15, carry the 1. What, 195 miles per hour? Or yowza, that's fast. That's pretty fast.
Almost as if that's a hurricane.
That is a hurricane. Duh. Okay, but that's pretty fast. All right, that's a real world number right there for you folks. So what we're trying to figure out is the air pressure when.
It like it'd be kind of fun to be picked up by a hurricane. Kind of like.
No, it wouldn't be. You'd get tossed around like a rag doll, break your limbs, and dismember you.
But it'd be kind of fun.
Velocity is like being inside a tornado. You don't want to be. Trust me. All right, it's 55.5 meters per second.
Is it not like a consistent air current? Like there are multiple contesting air currents, so it's like they're trying to.
Yes.
Like they're fighting over your body, so it's like they're hitting.
Yep.
You in different sections, so it's just turning you apart.
So what we're gonna do is we're gonna set this equal to this given value.
Is that M over S?
Yes. So we're gonna have 55.5 equals 6.3.
Is it 55.52 M over S or?
No, just 55.5 parentheses M over S. Okay. Okay. 55.5 equals 6.3. We have 10, 12 minus P. Okay. We're going to divide both sides by 6.3. All right. So we do that, and we're going to get 8.81 parentheses equal to the square root of 1012 minus P. Now, this is where we get back to what we were talking about yesterday. We're going to square both sides. Why? There is an invisible 2 out here. I don't know if you guys can see that. It's pretty lime green. Let me go with pink instead. A pop. There's an invisible 2 right here that is going to cancel with this one. Okay? This leaves me with the square, by the way, of 88.81 is going to be 77.6161 equals 1,112 minus P. It's going to get a little tight down there. Sorry, I meant to write smaller. Subtract 1,112 from both sides. Now, don't panic. You're going to get a negative number, but that's okay because we're given a negative P, which means we can divide essentially -1 from both sides and essentially cancel out the negative. That's good, okay? But after we get that, we get -934.384. All right, and that is equal to negative P over here. I'll move him over. Okay? Then I'm just going to write it, divide by -1. And our answer is going to be the pressure is equivalent to 934.384. Okay? That's a lot of pressure. The funny thing is, we realistically don't feel it, and there's a reason for that. So this is kind of gets into physics a little bit. For those of you in here interested in physics, let's talk about some physics here. Air pressure, as you know, gets thinner as you the air pressure gets thinner as you go up, right? Yeah, the air gets thinner, it's harder to breathe. Well, the thing is, think of the Earth's layers of air like an ocean. If you go in the ocean, there's varying pressures, right? The pressure at the top is pretty thin, right? Because there's not that much water pushing on you at that level. But the further you go down, the harder it gets. And it pushes harder and harder and harder until eventually it turns your bones to mush and squishes you like a pancake. So high air pressure is good for us. Low air pressure is bad for us. Low water pressure is good for us. High water pressure is bad for us. You see how this works? That's why if you're the crushing vacuum of space, the pressure out there is so astronomically high that no one could survive it.
That's why you need like special equipment so that you don't die.
When you're in space, you're literally wearing a atmospheric suit. You're basically wearing an atmosphere around you. Those suits, you're floating inside of the suits. So it's like when you're out and walk around space. So that's why if you're a diver, the lower you go down, that's why you need to wear a suit that actually pushes air around you to force the water away from you so it doesn't crush you.
That's also why.
That's why you have to be in a sub at certain altitudes.
That's also why if.
Okay. So that hopefully this just gives you an idea of where math applies in the real world. Yes.
That's also why if you it's not good if, say, hypothetically you were thrown into space. Don't like take the last breath of air before you're thrown in. That would be more painful because your lungs would collapse in on themselves and you would inflate more and it'd just be awful.
Yeah. Well, no, actually, it pulls the air out of you, so all the water gets pulled out of you first. Yeah. All right. So. Now, let's talk about just solving some general equations I want to go through real quick, okay? We're going to dial the difficulty with these from what we saw yesterday, all right, before we get into our new content, all right? But first, we're going to solve the following equations for x. The first one you have here is the cube root minus 9 plus 6. We're going to add 9 to both sides like we do, and we get the cube root of x equals 3, and we're going to cube both sides. So unlike yesterday, where we were just doing the perfect squares or squares, now the thing is, guys, it doesn't matter what the index is. All you're going to do is do the inverse power of it, i.e., you're going to take the power of whatever your index is. If it's the fourth root, fifth power, fifth root, fifth power, sixth root, sixth power, and so on and so forth, okay? I.e., as I showed you guys in your notes, you do the nth root is to the nth power. Whatever n equals, n has to equal the exponent. Okay, we do that. We get x equals 27. Okay? Pretty easy stuff there. The other one we're going to talk about is what happens when we even make it more complicated? We put a 2 in the front. Guys, it's just a coefficient. Divide both sides by 2. Okay? That leaves me with the cube root of x minus 3 equal to 2. Again, take the cube of both sides. That leaves me with x minus 3 equals 2 to the cube is 2 times 2, which is 4. 4 times 2 is 8. Very good. Okay, so add 3 to both sides. And we get x equals 11. Okay? Yep, don't worry. I want to get them all down, and then I will pause. All right?
Still trying to write down the first.
I know. The other one we've got is the square. On both sides, just square both sides. Nothing complicated there. X plus 24 equals 4. Subtract 24 from both sides. And we get x equals negative 20. Again, it is okay to have a negative number inside these radicals because in the grand scheme of things, all right, as long as that number results in a positive value after simplification, okay, then we don't need to worry about it. Okay, it can be as negative as it wants to be so long as it gives me a positive number underneath the radical. The last one, okay, we're going to divide both sides by 2. We get the square root of x plus 1. Square both sides. Okay, that becomes 4, and we're also going to square that. So we get x plus 1 equals 16. Subtract 1 from both sides, and we get x equals 15 as my answer. All right, so now that we've gone over these significantly enough to the point where you guys... Yes. Okay, now that we've gone over these significantly, let's talk about what happens when you throw inequalities into the mixture and make these guys essentially into expressions. Oh boy, things get weird. Okay, first things first. Radical inequalities are solved the same way radical equations. So just pretend the symbol's an equal sign for right now. Nothing's going to change majorly yet. Yet being the key word. All right? First things first. We're going to divide by 3. Right? Okay, we don't flip the sign, though, because even though we're dividing, that 3 is not negative. If it was negative, you would flip it, but it's not. Okay? So that leaves me with x minus 1 is less than or equal to 6. Okay? We're going to square both sides. So that means with x minus 1 is less than or equal to 6 squared is 36. Okay? Add 1 to both sides. And I get an answer of x is less than or equal to 36. Okay? Now, if you're ever in doubt, check it. Pick a number that's... You can plug 36 in for all it cares because it's technically less than or equal to. Remember that. If it's less than or equal to, you got your different symbols. So for those of you who forgot... Oh, it is 37. Whoops. Thank you, thank you. My bad. I just realized I lost the cap to my whiteout. Oh, well. Okay. Should be 37. Thank you very much for catching that. Okay, 37. Now, just a little reminder for those of you who forgot. That less than or equal to, that means, just for those who forgot the symbols, less than or equal to, greater than, or equal to. Okay, then you just have less than, greater than. Okay, so those are just a review of the symbols. Okay, this should be nothing new. You should remember covering this back in your previous math course. All right, now don't forget though, as we've stated just earlier, but don't forget, flip the inequality, okay, when multiplying or dividing by a negative number. Okay? All right.
Stay on this first.
Now, we're going to go ahead and work on the next numbers down here. Okay? So, let's talk about the first one. We have the square root of 5x plus 1 is greater than 6. First things first, let's just square both sides. Right? We get 5x is plus 1 is greater than 36. Subtract 1 from both sides. I get 5x is greater than 35. Divide by 5. And I get x is greater than 7. All right? Number 3, 1/4 times the square root of 3x plus 9 is less than 5. Subtract 9 from both sides. That leaves me with 1/4 the square root of 3x, is less than -4. Now, before you continue, my advice to you on this one is to multiply the entire expression by 4. Get rid of that fraction. No, this does not flip the sign at all. So we're going to multiply the whole thing by 4. And what that's going to give me is the square root of 3x is less than -16. Square both sides. Okay? I get 3x is less than 256. Divide both sides by 3. And I get that x is less than 85.33 repeating. Okay? Now, for those of you who have never seen this before, a line on top of a number just means it's repeating infinitesimally. That's it. Infinitesimally is a fancy word for infinitely decimals, basically. It keeps going and going and going and going, like the Energizer Bunny. Okay, it doesn't stop. So just draw a line at the top. It's kind of hat. It says, hey, here's a hat. Don't let your crazy hair go all over the place. Thank you very much. Okay? Number 2, we have the cube roots. We're going to cube both sides. That gives me x minus 5 is less than or equal to 27. Add 5 to both sides. We get x is less than or equal to 32. An easy one. Okay. The last one, we're going to subtract 3 from both sides. That leaves me with negative 2 to the 5th root of x is less than or equal to negative 2. We're going to divide by a negative 2. This is where the sign changes. Negative division, flip inequality. Okay, so that says negative division, flip inequality. I know it's kind of jammed in there, sorry. Okay, what that gives me then is the 5th root of x is less than or equal to positive 1. Oh, wait, I messed up. That should have been negative 4 back here. My bad. That's negative 4 divided by negative 2 gives me positive 2. We then take the 5th power to both sides, and we're left with x is less than or equal to, oh wait, no, that would be positive 4. Whoops, so that's positive 4. So 7 minus 3, positive 4, divided by negative 2, gives me negative 2 to the 5th root, and it stays negative because it's an odd power. If it was an even power, it would become positive. That gives me negative 32. All right, make sure you do the practice problems after this. Good luck.